In my last video, we defined what it means to be a function, and we did so using kind of what you see I have written here, but we said that all functions are really relations, and you see a couple of relations that I made here, where we say a relation is just some mapping of some input to some output, okay? But we say it is a relation in which every input goes to one and only one output. So what we determined was that this over here was a relation, but not a function, because we see that one mapped onto two outputs, but we see over here all of these inputs mapped only to one output. So what we're going to do in this video is we're going to talk about a little bit more about, at least, how we represent functions, okay? Because what you see here is what we refer to as a mapping, okay? And this is just one way that we can represent a function. A couple other ways that we're going to explore in this video happen to be in a table, so we say numerically, but also in a graph or graphically, okay? So let's go ahead and take a look at what we mean by representing these two relations in a table. Now you notice I have a couple of relations up here. We say A and B, we could call these. But we say for relation A, one other way we could represent this as an input-output relationship is in a table, okay? So you're going to notice that it says input and output up here on both of these, but what we're going to do is this. We're actually going to reach a little bit further, and in general what we're going to do is we're going to do something we do quite often, which is we're going to refer to as our X variable here, our input values, or our input values will be represented by some X variable, and we say all of our outputs will be mapped onto some Y variable. Okay, so for the sake of this video and from now on out, we're going to refer to as our functions or relations as being some mapping of X onto Y. But let's go ahead and represent that down here in these tables. So when I make my table, we say X and Y. In this first input bubble up here, you notice that we have -3, 1, and 4. Okay, and then as far as outputs go, we say we had 3, -2, 1, and 4. Now when we put these in, we have to be careful. Here's what we're really doing, okay? We're saying this input -3, it went to 3 when it got plugged into our relation. So we say -3 goes to 3, we're going to put -3 down here, it goes on to 3. Now when I look at my 1, now notice 1 went on to 2 outputs. So this is not 1-to-1. This is not a function because I had an input go to more than one output. But we say, okay, this could be represented as 1 went to -2. But 1, we could squeeze this in here, 1 also went to 1. And then we say, last but not least, 4 maps onto 4. So now this last relation over here, we say relation B. We can map it out in some input-output or XY table. So our inputs here, we say our X values are -3, 1. We declared 3, and we say also 4. And we say, looking up here, we say -3 mapped onto 3, 1 mapped onto 1. 3 mapped onto 1, and 4 mapped onto 2. And so what I want to do is I want to remark these, okay? We said that this was a relation over here, but we say not a function, okay? And we're going to talk about why again. But we say this over here, this was a function. We saw this above, okay? So when we said, well, why, again, was this a relation and not a function? We say, looking down here at this representation, it's a little bit easier to see that we had, look at this here, we said we had 1 go to 2 separate outputs. So we had an input go to more than one output. Remember again that our input are our X and our output are our Y. Okay. Now looking over here at our input-output table, looks like we had an output occur twice, but we see we're okay with this because we had 2 different inputs, each one going to an individual output. So just like when we look at this table up here, we said everything on the left only went to one thing on the right. Just because they both went to the same thing doesn't mean that each individually didn't go on to just one thing. So we have this right here, okay? Now the last way we're going to represent a relation in a function is in a graph, okay? So we say this right here, this is a table. We could also say numerically. So up top, we have our mapping. Down here, we have our table and numerically, and our last one is going to be graphically. So we say graphing. So let's go ahead and take a look at our first one that was just a relation. We say, now, when we represent a relation or a function, you know, graphically, what we're really doing is we're graphing points in the XY coordinate plane. So just really quickly, I suppose we need to review this. Let me get this graphing thing out of here. When we talk about the XY coordinate plane, we are talking about the intersection of 2 number lines. We say the X number line, or the X axis, okay, and the Y axis, or the Y number line. Okay. Important things to keep in mind is that 0, 0, we say this is the point 0, 0 in the middle here. It's got a name. We refer to this as the origin. I always remember this because O looks like a 0, and that's the X and Y coordinate of this point. Speaking of X and Y coordinate, that is how we will list any point in the XY coordinate plane. So when you list a point XY, what we're really doing is we're saying that, hey, at some X value here, X this one right there. We are sitting at the height y. So when it comes to graphing points, I suppose if we were to graph the point like 2, 1, it means that on my x number line, I'm going to go 2 in a positive direction, and I'm going to go on my y-axis 1 in a positive direction. So this would be, for example, the point 2, 1. Now, before we move on, I want to point out a few things here. We say that there are 4 quadrants. We're going to number them using Roman numerals. So we say 1, 2, 3, and 4. So if you want to go back and number them otherwise, go ahead and do that. But we say this is important. Up here we have a positive x and positive y. If you were in quadrant 2, we have negative x values on the left. So a negative x value, but we'd have a positive y value because we be above the x-axis. Down here in quadrant 3, we have negative x's and negative y's. If you were to graph negative x, negative y, you'd go left and down. And then over here, we'd go right, so we'd say positive on our x, but negative on our y, we go down below the x-axis. So all of this being said, we say, okay, now let's represent our ideas graphically, our relations graphically. So we say graphing our relations. We say the first one here was A. And I'm going to go ahead and put our xy coordinate plane out here, and I'm going to put my arrows on here because it is important. It does go on forever and ever. I'm going to label these x and y, but this first relation here says negative 3, 3. Now, underneath where I'm graphing this here, I'm going to write this a little bit differently. We say this is our relationship A. I'm going to write this as a set of points, and so we say negative 3, looking at our mapping here, went to 3. So that means when I plug negative 3 into my function for x, that I got a y value of 3. So there's 1 point on my relation. We say 1 also mapped to negative 2. We say the point 1 maps onto 1. Or the point 1, 1 exists because the x value 1 maps onto a y value 1. And then we say 4 for an x mapped onto 4. Okay. We say this is a set of points right here, but we're going to graph all these. So we say left 3 and up 3 would be my first point here. I'm going to go ahead and label this. We say left 3, up 3. We're going to label our next point. It says go right 1 and down 2. So we're going to graph this guy here. We say right 1, down 2 is that point right here. We say 1, 1. So I go 1 right and 1 up. So we say this is the point 1, 1. And we also 1, 2, 3. So we say 4, 4 also belongs on this graph of this relation. So we say 4, okay, 4. And we say, all right, well, this right here would be a graph of this relation. And this relation is no more than what we got out of our table. And our table is no more than what we got out of our mapping. Okay, so these are all related. Let's go ahead and make our second relation here. We say B, graph it. This one, remember, is actually a function. The first one, we're going to talk about its graph next, but we say this one, B, is actually a function. So we say negative 3, 3 is on this graph, just like it is on the second or the first graph, negative 3, 3. We're going to put this out here. We say negative 3, 3. We say, looking at this here, we say 1 goes on to 1, so 1, 1 is also on this graph. We say 1, 1. 3 goes on to 1, so we say right 3 and up 1. So this would be 3, 1. And then 4 maps onto 2. So that this was 4, we'd say, this would be 2 up here. And I'm sorry for writing all these stacked on one another, but these are just the different ways that we can represent relations and in turn functions. Okay, in my next video, we'll talk about how to identify a function just by looking at the graph. Cheers.